Are you looking to expand your knowledge and proficiency with one of the most widely used framework in modern software development? So you don't want to miss this video. In this video, you will gain a comprehensive understanding of the Spring framework, including its core principles, features, and benefits. You will learn about the powerful dependency injection mechanism, which allows for loose coupling between components and improving the testability. Furthermore, this video explores and explains how Spring dispatches the request and how the dispatcher servlet internally works, and especially how to easily switch between different implementations and services using this powerful framework. Also, I will walk you through all the necessary steps on how to get started with Git and GitHub. So I will show you the basic commands that each software developer needs to learn. Also, I will show you how you can manage your account. You will discover how to manage and create a GitHub repository to store your code and collaborate with others. And for this, we will be using two ways: the command line and also the UI from our IntelliJ. Whether you're a beginner just starting out with the Spring framework or an experienced developer looking to enhance his knowledge and proficiency with the Spring framework, this video is sure to provide valuable insights and tips that you can apply to your own coding projects. So why waiting? If you're new to my channel, just go ahead, hit the subscribe button and become one of us. Also, don't forget to join the community that we are building right now. Go ahead and join our Discord server where everyone is helping everyone. And also, that's the place where you inspire me and give me ideas for the next YouTube videos. So I would be happy and grateful to see you part of our community. And before we start, just take 1 second and give me a thumbs up so I can continue on producing content like this for you guys. If you want to get a certification of completion after finishing this course, just go ahead, create your account on my website and learn from there. After that, you will get a certification of completion and you can go ahead and share it on social media. Tag me and I will be more than happy to reshare it again and celebrate this accomplishment with you. That's it from my side. Let's go ahead and start learning Spring Boot. First of all, let's answer the following question. What is Spring and Spring Boot? So we will start with the Spring framework. So the Spring framework is an open source application framework for the Java platform. It was first released in 2002 and has since become one of the most widely used frameworks for developing enterprise applications in Java. The framework provides a comprehensive set of tools and features for building complex, scalable, and maintainable applications, including the following: dependency injection and inversion of control, aspect-oriented programming, data access and persistence, web and RESTful services, messaging and integration, and then testing and debugging. The Spring framework is designed to be highly modular and extensible, allowing developers to choose the components they need and easily integrate them with other third-party libraries and frameworks. It also promotes good coding practices and software design patterns, such as a separation of concerns, loose coupling, and abstraction, which make applications easier to maintain and evolve over time. Now let's answer the question, what is Spring Boot? So Spring Boot is a popular extension of the Spring framework that simplifies the process of building standalone production-grade Spring-based applications. So it provides a set of opinionated defaults and auto-configurations that allow developers to create applications with minimal setup configuration while still retaining the power and flexibility of the underlying Spring framework. So Spring Boot includes several key features that make it popular among developers, including embedded web server such as Tomcat and Jetty, automatic configuration of Spring and third parties, production-ready features such as health check and metrics, and then easy integration with popular tools such as Maven, Gradle, and Spring Toolsuite, and finally its developer-friendly features such as hot reloading, automatic restarts, and customizable logging. Overall, Spring Boot makes it easy to create standalone production-ready Spring application quickly and with minimal fuss. It is practically well suited for microservices-based architecture and cloud-native development, where speed, agility, and simplicity are highly valued. Learning Spring Framework can bring several advantages for developers and organizations. And here I'm gonna tell you 5 reasons why you should learn this framework. First of all, extensive support and community. Spring has a large and active community of developers with extensive documentation, forums, and resources available online. This makes it easy to find help, learn new skills, and stay up to date with the latest trends and best practices in Java development. And one of the best resources that I really recommend is the aliboucoding YouTube channel, where you can find so many diverse videos about Spring Framework. Then it's modular and flexible architecture. Spring's modular architecture allows developers to choose the components they need and easily integrate them with the third-party libraries and frameworks. This provides a great deal of flexibility and promotes good coding practices, such as a separation of concerns and abstractions. Then, the enterprise-grade features and functionalities. Spring provides a comprehensive set of tools and features for building enterprise-grade applications, including data access and persistence, web and RESTful services, messaging and integration, and testing and debugging. These features make it possible to develop complex, scalable, and maintainable applications with ease. Also, Spring is really easy to learn. Despite its power and flexibility, Spring is relatively easy to learn and use, especially if you have prior experience with Java development. Its annotation-based approach and comprehensive documentation makes it easy to get started and start building applications quickly. You are already following this tutorial, and this is gonna get you started with this framework. Finally, the most important reason to learn Spring Framework is career opportunities. Many companies use Spring to build their enterprise applications, which means that learning Spring can open up several opportunities for developers. Having Spring skills on your resume and CV can make you a more attractive candidate to potential employers and help you land high-paying jobs. So what are you waiting for? Go ahead, learn Spring, and don't forget that you have a really awesome resource that will help you learn Spring in depth, which is some guy called aliboucoding. So he has a really nice YouTube channel full of resources and videos about Spring Framework. So go ahead, subscribe to it, learn from him, and follow him on social media. To learn a framework and master its different components, you first need to understand and know what are the components that a framework brings with, and especially its own architecture. So this is what we will be explaining. First of all, we will start with the data access. The data access module is responsible for providing a consistent and easy to use abstraction for accessing different types of data sources in Spring application. And it includes, first of all, JDBC. This provides a JDBC abstraction layer that simplifies database access and transaction management and also helps avoid boilerplate code. Then ORM, which provides an integration with the popular ORM frameworks like Hibernate and JPA, allowing developers to map their applications' domain models to a relational database schema. And OXM provides integration with Object XML mapping frameworks, allowing developers to map between Java objects and XML documents. Next is JMS, provides integration with Java Message Service, allowing applications to send and receive messages asynchronously. Finally, transactions. It provides a declarative programming model for managing transactions across multiple resources. Also, Spring comes with a web module which provides APIs and utilities to build web-based applications with Spring, and it includes several parts. The first one is Servlet, which provides integration with the Servlet API, allowing developers to build web application based on the Servlet specification. Next, Web provides integration with popular framework like Spring MVC, allowing developers to build web applications in Model View Controller pattern, which is the MVC pattern. The next one is Portlet, which provides integration with the Portlet API, allowing developers to build web applications as a set of portlet that can be combined into a port. Finally, WebSocket, which provides support for real-time and two-way communication between the client and the server, allowing developers to build interactive web applications. The AOP module, which stands for Aspect-Oriented Programming, provides a powerful mechanism for modularizing cross-cutting concerns in Spring application. So cross-cutting concerns are those that span multiple components and can be factored out the core logic of the application. AOP allows developers to define these concerns as aspects and apply them to multiple components in a consistent and transparent way. The Aspects module provides a set of pre-built aspects that can be used in AOP-based applications. These include logging, caching, security, and transaction management. Aspects are reusable code modules that can be applied to different parts of an application to add functionality without affecting the core logic. And then the instrumentation module provides support for bytecode instrumentation, allowing developers to modify the behavior of compiled classes at runtime. These can be useful for debugging, profiling, and other runtime analysis tasks. The messaging module provides support for building message-driven applications using a variety of messaging technologies, including JMS, AMQP, and MQTT. It provides a flexible and scalable architecture for building event-driven systems. The core container provides the foundational building blocks for the Spring framework, and it includes Beans, which provides the Bean factory and related utilities for managing application components and their dependencies. The core provides core utilities and non-invasive ways of accessing low-level functionalities of the Java platform. Context provides support for advanced features like internationalization, resources loading, and event propagation. Finally, ESPL provides support for Spring Expression Language, which called also SPL, a powerful expression language that can be used to configure and manipulate application components. And finally, the testing module that provides support for testing Spring-based applications. It includes utilities for writing unit tests, integration tests, and end-to-end tests, and provides also integration with popular testing frameworks like JUnit and TestNG. Testing is an important aspect of software development, and the test module makes it easy to test Spring applications and ensure they meet the required quality standards. We cannot talk about software engineering without talking about Git and GitHub at least. So Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Git allows developers to keep track of changes to their code base over time, collaborate with others, and revert changes if necessary. Instead of relying on a central server, Git uses a distributed model where each developer has a local copy of the entire code base and can make changes and commit them independently. This makes it easy to work on different parts of the code base simultaneously and merge changes together when they are ready. So from this point, I encourage you all to at least know the basics of Git and learn the basic commands of Git. That will help you work with this tool and also push your code to some like GitHub, for example, which is here my GitHub account. So first of all, I invite you to follow me on GitHub so you will get notified and you will see the new repositories and code that I will be pushing. Also, if you want to connect with me, don't forget here, this is the part where you can connect with me on LinkedIn, Stack Overflow, Instagram, YouTube, and even you can join our community on Discord. About LinkedIn, I'm always posting useful posts about, for example, I already posted something about the basic commands for Git, how to use it, and so on and so forth. So I'm trying to post daily or weekly on LinkedIn, so go ahead and join me there. I would be happy to see you there. I want to highlight the fact why you should have a GitHub account. So having a GitHub account can bring several benefits for you as developers or students and even other professionals in the software industry. And the reasons I want to set here, first of all, with Git, you can showcase your work because GitHub provides a platform for developers to showcase their work and demonstrate their skills to potential employers or client. So I need you to focus on employers or client. I will come to this point later on. You can create public repositories to share your code and collaborate with others, or create even private repositories to work on personal projects. GitHub helps you collaborate with others and makes it easy to collaborate with others on projects by allowing multiple people to work on the same code base and merge changes together. This can be useful for open source projects as well as for collaborating with colleagues or clients. Also, with GitHub, you can contribute to open source projects since GitHub is the home to millions of open source projects, which means there are plenty of opportunities to contribute to existing projects and learn from other developers. Contributing to open source projects can help you build your skills and make valuable connections in the industry. Also, using GitHub, you can track changes and issues because it provides powerful tools for tracking changes to code and maintaining issues or bugs. This can help you track of your work and stay organized, especially on larger projects. And last but not least, build your professional network. GitHub has a large and active community of developers and other professionals in the software industry. By participating in this community, you can build your professional network, learn from others, and discover new openings. And finally, employment opportunities. Many companies use GitHub to find and recruit talents, which means having a strong presence on the platform can make you more visible to potential employers. GitHub also offers job posting and resume search features, which can be useful for job seekers. So I think I gave you enough reasons to go ahead and create your own GitHub account and start pushing and showcasing your own code. Also, if you like my code right here and one of my repositories, so I would invite you first, and also I would tell you that this is a good habit. First of all, go ahead, click and star the repository that you like and the repository that you learned from. Give it a star, so this is gonna motivate us and motivate me especially to continue on producing content for you guys. So that's it about GitHub. Go ahead, create your account, and see you in the next part. Now let's have a look on our future application. So we will be building an application that will manage students and persist them into a database. So we will be exposing 4 endpoints. The first one is a get, and it will allow us to fetch a student by its ID or fetch the list of all the students persisted into our database. Then we will implement a post that will allow us to save a student to the database, and then a put method or a put endpoint that will update the student informations. And finally, a delete operation that will help us deleting a specific student from the database using its own ID. This application will be based on the N-tier architecture, and it will be composed of 3 layers. The first layer is the controller side, and then the service, and then the repository, and all the information will be persisted to a database. This application can be consumed whether by a mobile application, another API, or even a web application. But this is not only what we will see. We will see also how we can switch between different implementation, because we will be implementing a service that will persist students into an in-memory database or just the memory, and another service which will persist the students into the database. And I will show you how we can switch between the different implementations. So here, this is the overview of our 2 different services. The first one will be an in-memory student service, and the second one will be a database student service. The first one will persist the information of the student into the memory, and the second one will persist the students into the database. And then I will show you how, through its power features, how it's able to switch between these 2 implementations based on a small configuration that we will need to add. And then you will be able to understand how Spring is able and capable of dispatching a request. So from the incoming request until it finds the correct endpoint and the correct method to execute, and then going up to the database and then coming back with a response to the final user. So this is the overview of our full application that we will be implementing and what you will learn in deep in this course. So I'm super excited to start implementing this application. Let's go ahead and bootstrap our application. First of all, we need to create a new Spring Boot project. And for me, my preferred way and the way that I recommend so much is using the Spring Initializer website. All you need to do is to go to start.spring.io, and then you will have this really nice looking interface, and then I will walk you through all the information that you need to fill in order to create a new Spring Boot project. First of all, here we have the project. So which tool that we want to use in order to manage our dependencies. So it can be Gradle for Kotlin, or Maven. So for me, I prefer using Maven. I will go for Maven. If you want to go with Gradle, it's up to you. Then you can specify which programming language you want to use to implement this project. And for our case, we will be using Java. You can also use Kotlin or Groovy. And then you need to select one of the Spring Boot versions. So we have here the 2.7.9, and also we have the most recent version, which is the Spring 3. And we have also the 3.1 and 3.10, M1 and Snapshot, but they are not final yet. So we will be using the 3.03 version. Then let's move on to the project metadata. So the project metadata are the information or the metadata information of our project. And here we will define our group, which will be com.alibou, and then the artifact of this project. So I will call it Spring Demo. Then here you can give a name for your project. So I will leave it as Spring Demo, and then the same for the description, which is also fine and suits perfectly our project, demo project for Spring Boot. And here I will just add for complete beginners. Then you see here that it's auto-generating the package name, and it will be finally com.alibou.springdemo, and this is what we will be using as a final package name. Then you can choose the packaging, and since we are using Spring Boot, so I recommend you go for a jar packaging instead of Word packaging, because with jar packaging we already have an embedded web server, Tomcat, or you can switch it later on to Jetty in order to use it and start the application in standalone mode. Finally, we need to specify which Java version we want to use. Here I need to highlight that with Spring Boot 3, the minimum required version is Java 17. Also, you can go with Java 19 if you want to. So for me, I will keep it Java 17. And then let's move on and talk about the dependency. As I explained before, Spring Framework and Spring Boot uses a set of libraries in order to provide us all the features and all the modules that will help us implement and build our web application. But for some features, we need to provide our own and specify and tell Spring which dependencies that we want to use in order to build our project. And since we said that we want to build a RESTful application, so the first thing that you need to add as dependency is web. So go ahead and search for web, and you will see that you have a dependency called Spring Web. And this one, as you can see in the description, build web including RESTful application using Spring MVC, and it also uses Apache Tomcat as a default embedded container. So go ahead and select this one. You can also add as many dependencies as you require for your project, but for now we will be building only a RESTful web application. So I will use only for the moment our Spring Web, and then I will show you how you can manually add other dependencies if you need them. So once you finish adding all the dependencies that you need, all you need to do is to click on generate, or you can also explore the project that will be generated for us. And as you can see here, this is the pom.xml file, and also you can navigate to the source and so on and so forth. And this we will see just in a few moments. I will walk you through all the structure of the Spring Boot project, and I will explain each file independently. So go ahead, click on download, and then open this project within your preferred IDE. Wow, that's awesome. You made it this far. So now you know how to create a Spring Boot project, how to manipulate the Spring Initializer website, and even you started the application and you are running now with your preferred IDE. So for me, I prefer using IntelliJ as an IDE, and I got a lot of questions and a lot of comments about this nice looking UI. So this comes with the latest version of IntelliJ, and it's just a beta UI. And if you want to enable it, all you need to do is go to IntelliJ and then settings, and here you will see that you have this new UI and it's called beta. So it's not final yet, and all you need to do is to enable the new UI and then click on OK, and then it will ask you to restart your IDE. Alright, since you have the nice looking UI, you have your project opened and ready to use. So let me first walk you through this project and the structure and each file that we have within our project. So first of all, let's start with the pom.xml file. So this file is the project object manager, which will manage our project. And as you can see here, first of all, it contains the metadata that we specified while creating the project, the group ID, the artifact, and here it comes with the default version, which is 001 snapshot. And then we have the name and the description of our project. So again, what makes a Spring or a project, a Spring Boot project, is that extends this parent project, and this parent project is the Spring Boot starter parent. And as you can see, since we chose the version 3.03, it's already specified here. So if you want to change the version, all you need to do is change this one right here, update your project, and you will have the latest version or the newest version that you will choose. Also, if you scroll a bit down, you see that we have the properties right here, and among the properties mentioned is the Java version that we chose, which is Java 17. Also, if you scroll a bit down, in the dependencies level right here, so those are the dependencies or the libraries that we will be using to implement our project. Since we added only one dependency, which is this Spring Boot starter web, so we see it included already in here. And I already mentioned before that Spring Boot provides a test module that will help us implement tests for our application. So you see it's an implicit integration of this Spring Boot starter test library. So this is our pom.xml overview, and then if you scroll a bit down, you see here that we have this a set of plugins where we can set them, or where we can define our own plugins. But this part maybe we will come for it later on or in a different tutorial. Then we have a bunch of other files. So this is the git ignore, and this is where you can define all the files that you don't want to stage or to version, or also to make it easy for you, all the files that you don't want to commit and push to your own repository. So if it's the case, all you need to do is to specify or to add a line into this file. Then we have this help.md file, which is, you can consider it as a README. We will rename it later on and we'll make it the README file for our project. And the README file is an important file that everyone needs to take care of, because it's the mirror of your application and repository. So every time you go to repository, and you will see a nice looking web page, including the source, and if you scroll a bit down, you will see the README file, which will be automatically rendered by your GitHub or GitLab. Then let's have a look on this source folder. You will see that you have two main folders or subfolders right here. So we have the main and we have the test. So the main is where we will be adding or creating all the classes that we will implement for our application. And then the test is the test folder that will hold and contain all the test files that we will be implementing or you will want to implement. So let's have a look on this main. This main is also composed of two parts. The first one is the Java, and the Java contains all the Java files, classes, entities, beans, configurations, and so on and so forth. It will contain all the logic of our applications and the files of our applications. Then we have this resource folder right here, and as its name mentioned, so it's a resource folder. Here we see that we have this application.properties file, and this one is where we can define whether the Spring properties for some starters. For example, if you want to connect to a database or if you have security, you can add the properties in here. So Spring will read this file at the startup. So the first thing that Spring will do, scanning the whole project and then start reading and uploading these properties into his context. So here for this application file, so there are two representations. There is properties representations, which will be inline. So for example, you can use it in this way. So it's Spring, or let's make it easier. So ali.prop1.value equals 1, for example. And then if you have a second property, it will be ali.prop2.value, and so on and so forth. So this is how properties representation looks like. Also, my preferred representation is YAML. So if you rename this file, by the way, you can see all the shortcuts that I'm using right here. There is a green pop-up will show each time I use a shortcut, and I will make a specific video for that, how to use or like the best shortcuts to use within IntelliJ. So to rename this file, I used the Shift F6, and then I will change the file or rename the file from properties to YAML. So YAML, there are two ways, whether you can write it with A or without A. Both of them are valid and Spring will be able to read it. And the YAML representation, it will be something like that. Ali, and then colon, and then prop1, and then value, and then 1, for example. Then if you want to add a second property, it will be prop2, and then value, and then 2. So this is the difference between YAML representation and properties representation. So for me, the YAML representation is much readable, and I prefer working with YAML. If you want to use properties, it's up to you. And finally, we have this generated class called Spring Demo Application. So this class will be automatically generated out of the name of our project, the one that we specified right here. So you see here it's Spring Demo, and then it automatically generated a Spring Demo application file. So first of all, I will just go ahead and fix this small typo, and demo I will make it with a small with a capital D, and then okay, because it wants to also update the source file, the test file. So here, let me show it to you, and I will also rename this one because we made a small mistake or a small typo. It's not a mistake, just a typo when we created our project. All right, now let's go back here. You see that in this file we have this Spring Boot application. So this Spring Boot application annotation will tell Spring that this is our main class, and here we want to privilege and we want to enable all the auto configurations, because as you know, Spring Boot comes with a lot of auto configurations based on the starters that we want to include or that we will include into our pom.xml file. Finally, this is the entry point of our application, and this is the file that we need to run in order to start up our application. So now you understood everything about the project, the structure, and the different files that were auto-generated by the Spring initializer. Let's now go ahead and start the application and see what will happen. There are different ways to run the application. So the first one is you just need to click on this run button right here and it will run the application. The second one, you can click on this green play button right here also to run the application. Or the third option is to right click on this file and then we have run Spring demo application. Or also like a fourth option for you, if you select the file right here, right click and you will also have this run Spring demo application. So let's go ahead and run it in a classic way and let's see how the logs are going to pop up, and let me explain a bit what's going on. So our application is up and running. And then if I scroll up, you see here that we have this nice looking banner, and I will show you later on how we can update or how we can change this banner. Then you see that we have some logs, Spring Boot application using Java 17, started by aliboucoding. So this is like the owner of the laptop. Of course, it's me. And then it says that we have no active profiles. This is something that we will see later on. Also, we see right here that Tomcat initialized with port 8080. And as you remember, we did not add any Tomcat or we did not add any dependency that says that I want to have a server. But Spring Boot, as I mentioned before, comes with a default embedded web server, which is by default Tomcat, and then you can change the configuration. You can exclude Tomcat and inject Jetty instead. But let's keep everything as default. And then if you scroll a bit down, you see here that root web application context, and then we have initialization completed within 1023 milliseconds. So Spring is quite fast at startup, and it depends always on the machine. So if you run it on a powerful machine, it will run really fast. Otherwise, it might take some time. All right, so now our application is started. Let's try to access this endpoint. So you see here, this Tomcat is running on the port 8080. So let's try to access this web application. Now, if you go to the browser and try to access the localhost 8080, first of all, it will show this whiteable error page. Why? Because we don't have any page or we don't have anything by default for this address. But this means that our application is running and we don't have any page for that. So let's go ahead and add something and display it in here. Let's add an index.html page and make it our default or our entry page for the whole application. So here within the resources, go to the static folder, right click on it and then create a new file and then call it index.html. And in here, I will just add an h1 or a heading 1 and I will call it hello world and then alibou. And then also let's say Spring for beginners. Now, all I need to do is to restart the application and go back to my browser and check the result. So now if you go to the browser and refresh the page, you see that we have this nice looking message, hello world, alibou, Spring for beginners. And now let me explain what happened exactly. So at the startup, Spring will start looking for default configuration or a default file called index.html, which will be the root page or the root display of our application. So if you don't have any mappings or any controllers yet to access them fully with the full URL, Spring will try to rely on a file called index.html. So I just added this in order to not to have this error page when we try to access our localhost 8080 address. All right, so now we have our project set up and running. So can you answer the question, what comes next? Yes, I think you got it. The next step is creating a repository on GitHub, and then git commit and git push. So let's go ahead and do it. So the first step is creating a new repository. And to do that, here next to your icon, after creating your GitHub account, of course, and logging into your account, go ahead, click on this plus icon right here, and then you have new repository. Click on it, and then you will have this page. I'm gonna zoom in so it looks maybe more readable. And then you have the owner. You might have multiple owners, and then you need to specify the repository name. So I will call it springboot for beginners. And here you see that it's checked. So if the repository already exists, it will be red and it will tell you that you need to choose a different name. Then it's an optional to add description. After that, you need to check, or you need to choose the visibility of your repository, whether you want it to be a public, so everyone can access this repository, or a private, so it's only you and the allowed people that you want to authorize to access this repository. Then you can initialize this repository with a README file or a git ignore, but for our case we will not do this because we already have our code and we want to initialize the project from there and push everything from there. Okay, so now just go ahead and click on create repository. Now we have our repository already created, and here you see that you can set up in desktop. You can download a desktop tool to manage or to work with Git, or you can use command line, or even you can use IntelliJ or the UI from IntelliJ to push and commit and manage your repository. So here we have two ways. The first one is HTTPS and the second one is an SSH. So for the SSH, you need to set up an SSH certificate and you need to configure it on your GitHub account to be able to use SSH to push, pull, and update your project. Here you have also the steps that you can follow in order to set up a new repository or to push an existing repository from the command line. So this one, we will be using it because we will start from a new repository and we will follow these steps one by one. Let's follow these steps and let's create and push our code into this repository. When you go back to your IntelliJ, you can open a terminal right here, or you can use your system terminal to do that, but let's do it from here. So first of all, make sure that you are in the root folder of your project where you have all the source code and everything together. And then, as you can see in here, the first command is git init. So this git init will initialize this project and transform it to a Git repository. So here we see that we have some warnings or hints, and then it says that initialized empty Git repository and so on and so forth. Next step, we have here git add readme.md and then git commit -m first commit. So this one is to commit and the -m is to provide a commit message. And then we can set up the branch. So you don't need to follow one by one or like to follow these steps. Literally, you can just mix them, but you need to mix them in the correct order, of course. So first of all, before adding or before doing anything, I want to set my branch to main. I will copy and paste this command. So here you see it was working, and even up here you see that the main branch now is called main. Next, I will add the remote, or let's even check what is the status of our repository. So if you execute the command git status, you will see that you have this message right here. You are on branch main, no commits yet. We don't have any commits yet waiting to be pushed. And then we have this bunch of untracked files. And then it's already telling us to use git add and then the file name to include in what will be committed. So here it's also okay to it is okay to add and push all these files. So let's go ahead and add all these files at once. So you can whether use git add and then you can specify or precise the file name. So for example, I will first of all add the git ignore. Or if you want to add all of this, you can do it at once. But first, let's execute again the git status command. You see that now we have changes to be committed. We have a new file called git ignore because our file is now staged after we executed the git add command. Now I will add all of them at once. So I will do git add dot. So git add dot, it will add all the files on this root folder. So you need to be really careful when using this command because it might add unsuitable or files that you don't want to add. All right, so we added all the files, git status again. And you see now we have all these staged files. I'm gonna make this one a bit bigger, and we have the git ignore, Maven properties, and so forth. Then let's follow the next step. So here you see the next step is to commit. Committing means that I want to commit or to validate the changes that I have locally. They are not yet pushed to the remote branch. And when we say remote branch or remote means GitHub or the server that we have right here. All the changes remain locally until we push them. So let's go ahead and create a first commit. And to do that, let's execute the following command. Git commit -m for message, and then don't forget the double colons, and here I will say initializing springboot project. Let me clean this, and now let's commit our changes. So here, as you can see, we have this message initializing springboot project, which is our commit message, and then we have 10 file changed, and we have the list of these files. So if I do git status again, you see that on branch main, nothing to commit, and working tree clean. I will clean again this one, and I will try to do a git log and see what we have. So for this git log, we see that we have only one commit message or only one commit that needs to be pushed to the main branch. Now let's go and push these changes and check how it's gonna look like on our GitHub repository. So I will go back to the GitHub webpage, and to push is using this command. So git push -u origin main, and this is only for the first time, and then all you need is just git push, and also git push is sufficient for us. So let's try it. Now I want to push my changes, so I will use the command git push and then hit enter. And then because it's the first time, so here we have a small issue, and this is one step we just did not do yet, but I want to show you what's happening. So here we have no configured push destination because we don't have a remote yet. So that's true that we have Git controlling this repository or this project right here, but it's not yet linked to a remote. So in order to do that, all we need to do, let's go back to GitHub, and here we need to set up this one. So let's copy this command and let's paste it right here. So it's git add a remote, and then we have origin. So this is the origin, and I want to link my local one or my local repository to this remote repository. And now let's hit enter to set the remote. So command successful. I'm gonna clean this up again. So let's push this to the remote branch. So for this, let's go back to the web page, and let's copy this command because it's the first time we push this. So we need to specify the origin and the remote. Paste this one right here and then hit enter. So then if you are setting up your SSH, it will interrupt you and ask for your passphrase, or you can also configure it to be always persistent. And then you see that we are pushing to the branch main. And if we go back to our repository on the GitHub account, we will see that we have our code pushed. So now if I refresh the page, you see that we have this repository getting created. That's amazing. Now you have a running Spring Boot application, and also you managed to push the code to a new repository on GitHub. And also you learned some GitHub basic commands. So now it's time to build our REST API. But before that, let's first define and let me explain to you what is REST API. So first of all, REST API stands for, now I will explain the REST. So REST stands for Representational State Transfer, and API stands for Application Programming Interface. And REST APIs is an architectural style for building web services that uses the HTTP protocol to exchange data between the client and the servers. It is a set of guidelines or constraints that developers can follow when building web services to make them more scalable, flexible, and reliable. In a REST API, resources are identified by a unique URI, which stands for Uniform Resource Identifiers, and the HTTP methods, which are get, post, put, delete, etc. Those two are used to manipulate those resources. For example, a client can send a GET request to retrieve data from a server, a POST request to create new data, a PUT request to update existing data, and delete request to delete data. REST APIs typically use a stateless client-server architecture, meaning that the server does not store any session data about the client. Instead, each request from the client must contain all the information necessary to process the request. In addition, REST APIs usually support multiple data formats, such as JSON, which stands for JavaScript Object Notation, or XML, which stands for Extensible Markup Language, so that clients can choose the format that best suits their needs. One of the main benefits of REST APIs is their flexibility and scalability, because they are based on the HTTP protocol and they can be accessed from any programming language or platform that supports HTTP, and making them ideal for building web applications and services that need to be compatible with multiple devices and platforms. Overall, REST API is a powerful and widely used approach to building web services that offers many benefits, including scalability, flexibility, and compatibility with different programming languages and platforms. So now you know the definition and you have a first understanding what is a REST API and what means a REST API. So now let's move on and start building our first API. Now let's create our first controller. But first, let me give you a brief definition of what is a controller. In Spring Framework, a controller is a component responsible for processing incoming requests from the user and generating a response. It sits between the web server and the application business logic and is responsible for handling the various aspects of the request-response lifecycle. Controllers are typically implemented as Java classes that are annotated with Spring annotation called controller, or one of its specialized variants like REST controller or request mapping. These annotations allow the framework to identify and manage the controller as a Spring component and map specific HTTP requests to the corresponding methods within the controller class. And I will be explaining all this in details in few seconds afterwards. So controllers typically receive input from the user via HTTP request parameter, header or request bodies, and use this information to invoke the appropriate business logic or service layer methods. Once the processing is complete, the controller generates an HTTP response to be sent back to the user, typically by returning a view name or serialized object as JSON. Now let's move on to our IntelliJ and create our first controller. So now within our IntelliJ, navigate to the base package of our application, which is com.alibou.springdemo, and then right click on it, new, and then class. So our controller will be called student controller. So we can just call it student, but to follow the naming strategies and the naming conventions, let's call it or give it always a suffix controller. And for better organization, I will place this controller into package called student. So within IntelliJ, if you give the package name dot class name, it will automatically create a package, and inside it, it will create this student controller. So here, when using IntelliJ and you have your project versioned, you will be asked if you want to add the new classes that you will create to Git or not. And for our case, let's ask it to not ask again and always choose add. So like this, all the new files will be automatically staged. So as you can see right here, we have our student package, and inside it, we have our student controller. So as we mentioned before, we said that a Java class, to make it a controller, we need to annotate it with one of the following annotations, whether a controller or a REST controller. So for our case, let's go with REST controller. And as you can see here, we have this REST controller here. Let me make this full screen. And then when you create a controller, so this means that you are exposing a resource. So always think about giving it a mapping. And to do that, we need to use an annotation called request mapping. And this request mapping annotation, it takes a string as parameter. And this string is the path of this resource. So for the naming conventions, a REST API should always start with /API, and then always think about giving a version to your API. And then the resource name, which is student, and as a convention, the resource should be always in plural. If you want to expose student, it should be students. Now let's create our first method. So as we saw in the diagram, we have several methods like get, post, put, and delete. So now let's start with a get endpoint. So first of all, I will create a method public, and I want to return a list of string, and then I will call it find all students, for example, and then we will improve this. So now what we need to do is to return a list of string. So simply let's do return list dot off, and then we can specify many elements or multiple elements. So here I will call it alibou and then hello world. Now how we can make this method an endpoint or a get method. So simply we need to add an annotation called get mapping, and this get mapping, it also takes a parameter, the URL that we want to use to expose this resource. But since we are implementing REST APIs, so the namings says that get mapping and accessing these students is enough for a get method to fetch all the students. That's nice. Now let's start our application and try to check what is the output of this endpoint. I will run the application, and then let's go to our browser and check what will happen. So my application is up and running. Now I will open my browser, and then in order to access the endpoint that we just created, which is the following, /API/v1/students. And then for this get mapping, we didn't add any extra parts or fragments to our URL. So it's only this part right here. So I'm going to copy it and then paste it in my browser. And then I will paste it here and hit enter. Wow, that's nice. Look, here we have our list right here, and it contains two elements. The first one is alibou and the second one is hello world, exactly as we implemented it. So this is really nice. Now you have run an application and you already exposed your first endpoint. Let's go ahead and try how we can improve this, how we can implement our service layer for the application, and how we can handle our students. And of course, let's not forget our git commit and git push. So for this time, I will show you how you can use IntelliJ to commit and push, which I honestly like so much. So if you click on this git right here, or if you use command F9 to display it, you will have this interface. And this interface, it will list all the local changes that you have right here. And then you have here the log. And the log, this is all the logs that you have for your project. So as you can see right here, we have two commits, and the first one initializing the project, and the second one, which I did afterwards in the background, which is just adding the README file. All right, now let's go ahead and commit this one. So to commit using the user interface right here, whether you click on the root folder that you want to commit, or select only the file that you want to commit. So for this case, we want to commit this whole student controller, which is inside this folder. And now click on this icon right here. It's also called commit, or you can use Command K, and it will display this interface right here. So then you will have the list of the changed files, and make sure that your file is staged. So staged on IntelliJ means that the file will have this green color. If it's not staged, it will have a different one. I think it's red or orange color. Then you will need to add the commit message. So here, let's say building the first API. Let's call it sample API. All right. Also here you can, before you commit and push, you can check all the changes if you changed something. So we will keep pushing and committing using this UI tool, and each time I will show you if there is something that you need to know. Then you have this commit button right here, so you can commit and later on push, or you can see in this drop down right here, you have the option to commit and push at the same time. So for our case, we want to commit and push, and let's go ahead and do it, and then click on push. So here it's just displaying the commits that you will push to the remote. And here also you have the branch, so you make sure that it's always the correct branch and it's always from the origin. Now to push, all you need to do is to click on this push button. And then you see that we have this pop-up right here, pushed one commit to origin main, and then one file committed, building the first sample API. All right, that's good. Now let's move on to the next part. Since our application is managing students, so the first thing that you need to think about is creating this model. So the application will receive and expose resources, which is student. So always keep in mind that you need to create these resources or this model for that. So as a first step, let's go ahead within this folder, student right here, the package, right click on it and then Java class. And let's call it student. I'm gonna make this one full screen, and then our students, it's a model and it has attributes. So let's create the attributes. So first of all, private string first name, and then private string last name, and then private local date, and this is gonna be the date of birth. Then I want to give it also an email of type string. And finally, the student has an age. All right, so this is our student object. Then we need to generate getters and setters, because Spring in the background is using the reflection. And for the reflection, they need to use getters and setters. So always think about having getters and setters for your objects. All right, I'm gonna generate that. So I'm using shortcuts, and as a reminder, you can always see the pop-up right here. And here we see that we have the shortcut, getter and setter, and I want a getter and setter for all the fields. So I will select all of them, hit enter, and now you see that we have all the getters and setters. Next, I want to generate a constructor. So for this constructor, I can generate a constructor with all the information or an empty one, but I need a constructor with all the attributes. So I will create a full args constructor. Now let me just inline this one. All right. So yeah, like this, it's more readable for you. This is how our class student looks like. So we have fields, we have constructor, and we have getters and setters. Also, if you want, we can generate an empty constructor. Let's generate this one. So you just select the top right here and then click OK, and it will generate an empty constructor for you in case you need an empty constructor. All right, so now we have our student class. Let's go ahead and now, instead of exposing a list of string, I want to expose a list of students. Now, if you go back to the student controller and to our method find all students, instead of exposing a list of string, here I want to expose a list of students. So the first thing that I need to do is changing the return type here. Instead of string, I want to say student. And then here I will change it. So I will return a new student, and then I will specify the first name, Ali, and then last name, Bo Ali. And then I have the birth date, let's say local date .now. And then I need an email. So it's gonna be this contact at aliboucoding.com. So this is my email address. And finally the age. So let's say this is my age. And then now you see that we have one student getting exposed. So I will copy paste this one. I will expose two students. So this one is Ali. So the second one will be this guy right here, and the same email. And I will change also the age. And now let's start our application and check the changes. Okay, the application is up and running. I will open the browser again and refresh the request. So this is the old one, or like the old result from the previous request. Now I will just need to refresh the page because it's the same endpoint. And here you see that we have this JSON object. So first of all, this is a list. So this symbol means that this is an array or a list, and this one, it contains two items. And each symbol of this means that this is an object. And you can have a list of objects, and this object can contain also another list or another object, and so forth. So as you can see here, we have the first name, last name, and we have the date of birth, also the email and the age, and the same for the second student that we created. That's good. So far, it's perfect. Now I want to go back to my code and delegate this find all students or get all students. I want to delegate it to a service. So we need, or I want to implement a service layer for my application. Since we are working with the n-tier architecture, and in this example, it's 3-tier architecture, so then we need to implement this service layer. And the service layer is represented in Spring with a service class. So it's a Java class which will have the role of the service. So let's go and create, first of all, this service class. Now I will open my project here. I can close all this. And then within the same student package, right click on it and create a Java class. I will call it student service. So here I have my class created. Now to tell Spring that this is a service and this is a bean or a managed bean, and also if I want to transform this object, like I want to explain it in different ways. If I want to transform this object to a managed bean, all I need to do is to add one annotation. And for this, we have three annotations. We have component, repository, and service. So the service is the one representing the service layer. Component is a generic one if you don't have any logic classification for that component. And then you have repository when it's about getting or dealing with the data. So in this case, our student service is just a service. So I will give it this annotation service. And this one comes from org spring framework .stereotype. So that's it. Now our class is a service. So let's go ahead and implement our getAllStudents method. Now I want to move the implementation of this findAllStudents method to my service. So I don't want to have the implementation in the controller, but I want to delegate this business logic to the student service class. So first of all, I will just be copying the whole method like this, and then I will just clean it up. So I will remove this return. For the moment, I will say return null. Now let's go to our student service. I just copy pasted because it's the same thing and we want to return the same object, the same everything. All right, so now we have our find all students. Let's go ahead and call this service inside this controller and make or create a binding between our controller and our service layer. Now let's display again the list of the students. So before that, let me start the application and show you that the same endpoint will return null because here we don't have an implementation yet. So So in my browser right here, if I refresh the page, you see that nothing is returned and I have this white page. So this means that we have nothing getting returned by our backend. So now I can stop the application. And now let me show you how we can display the list of students based or like using this student service. So first of all, we need to create a variable of type student service. And I will call it just service for a short name. You can also call it student service. And here, all I need to do in this return null, instead of return null, I want to return service dot find all students. And that's it. But before that, my object is not yet instantiated and I don't have a running instance for this student service. So all I need to do is this. Alright, so now if I start my application and refresh the page, I will see that I have the student list. Alright, if I go back to the browser and refresh the page right here, you see that we have the student list again displayed. So let's go back to our IntelliJ and let me explain one thing. Alright, here we see that we are manually creating and instantiating the student service, and this is what we call tightly coupled application because we rely on the instance of this student service. This means that Spring Boot or the Spring framework or our Spring container is not managing the life cycle of this student service. Why? It's all because of this new keyword. So we need to get rid of this and delegate this operation or the creation and even the whole life cycle of this bean to the Spring container. So let's move on and let me show you how we can do this. Before I show you how to inject an object or how to inject a bean with Spring, before going to the code, let me first explain to you how this dependency injection works. So here we have our Spring container, and at the application startup, when the Spring container starts, first of all, it will start loading all the beans into its context. And here when we say bean, it's any object or any kind of object that has one of the following annotations. So if it's annotated with a bean, component, service, repository, and we have many other annotations that will mark an object as a bean. So here we have our student controller. So the application now is running and we want to use our student controller. And you know, the student controller uses this student service in order to fetch the list of students. And you remember that this student service has already this service annotation. So the student service now is considered as a bean. So it already exists within the application context. So when the student controller object require an object of type student service, then Spring will come and inject this student service into the student controller. So this is what we mean by dependency injection. So the student controller is dependent of this student service, and then the student controller doesn't need to manually manage and deal with the life cycle of this bean or object. So we want to delegate this operation to our container. So the Spring application or the Spring context will try to inject this object if possible, of course. So if you have an object which is not a bean, Spring will not be able to inject this object for us. So now I guess you have more understanding what is a bean, what happens exactly when we load the application, what Spring do exactly internally. Let me show you within the code how we can inject a bean into a different bean. So now let's go back to this student controller and let's remove this manual instantiation. And then just to remind you again, our student service has already the service annotation. So it's again a bean. So now I want to inject this student service into this student controller. So the first way is we call it the field injection. And to inject a bean, there is a keyword, there is an annotation that we need to use in order to tell Spring, hey, I want to inject this bean into my class. And this annotation is @AutoWired. So this AutoWired will tell Spring that, hey, I want to inject this student service object into this student controller. Now, if I restart the application and run again on my browser, you will see that we have the same list of students that we already displayed before when we manually created the instance of this student service. So let's restart the application and let me show you this. Alright, now if I just refresh the page, I expect to have the same list. So let's go ahead and refresh it. And you see we have this list once again. And if you make any changes to that list, you will see it immediately. So now our object is injected into our student controller. Let me show you a different way how you can also inject a bean. So now we see that we have the student service. I will create a constructor containing this student service as parameter. And now I will move this AutoWired to the controller, to the constructor of my controller class. So now this we call it the constructor injection, and the first one it's called field injection, but it's always recommended to use constructor injection instead of field injection. Now I will again restart the application and test it, but just to ensure you, I will have this student, I will rename it. So for example, student 2, and the name, I will keep the rest of the information as it is. Alright, now I will refresh the page. And now you see that the second student is called student 2 as we mentioned it in the code. Again, I want to explain something important since we are using a recent version of Spring and there were some changes. So let me explain to you what happened exactly. So within our student controller right here, you see that we are using this keyword AutoWired. Now I can even remove this keyword, and then Spring will be able automatically to inject this student service into this student controller. And how is this happening? So Spring, because this student controller is also a bean, because it has the REST controller annotation, which is also one of the beans annotations. So when Spring will create or will instantiate this student controller, it will see that this student controller has a parameter of type student service. So it will start looking into its context. Let me show you with a diagram. So again, when Spring will try to instantiate and create an instance of this student controller right here, again, it will look and see that the constructor contains already a parameter, and this parameter is of type student service. So Spring, what will do, he will look up into his bean or into his application context and will try to find an object or a bean of type student service. And every time it will find it, it will automatically inject it. So there is no need anymore to add the AutoWired keyword to the constructor or even the field. All you need to have is a constructor with all the beans that you want to inject into a specific object, and Spring will do the job for you. So again, all I need to do is to have a constructor within a parameter of my beans that I want to inject. Now let's restart the application, and before that I will name this to student 3 to always make sure that I have the correct list and that I don't have any exceptions and errors in my application. I will refresh the page right now, and you see that the student is now student 3. So this is really awesome. So now you know how to inject beans, and you know even how Spring is working and how Spring is preparing all the context with all the beans which are required for my application to work. Again, I want to show you how we can improve our code and have a really high quality code. So let's see what we will change. Before we go to the improvements, let's first git commit and git push. So here you see that we have 3 files to commit. These 2 are green, so they are new files, and the one in the middle, it's just updated because it's in blue. And here you can see the changes. So the green part is a new part, so it's something that we added. And the blue one, like the gray one, it's when we remove something, and the blue when you update something. So now you know like the colors code. Let's go ahead and commit this. So I will be committing and pushing all these 3 files, and here I will call it implementing service layer. All right, now I will commit and push, and that's it. So as you can see here, we have our student service, which is a class. And it's always recommended to have an application closed to the modification and open to the extension. It's always recommended to use interfaces and then implement them. Like the case, for example, if you use list and array lists. So we always use list as a type, which is an interface. And then, as you can see here, the list is an interface, and you want to create an instance of this list type, you just use array list. All right, so let's go with this. First of all, I will transform, or let me first of all read. So first of all, I will make this one an interface, and then I can remove this service annotation because it's just an interface. Let me optimize the imports and make it full screen. Then you know the interface, it has no implementation except if you want to have default interface, but it's not the case. So I will be copying this one. And then you can also remove the public keyword. Now let's also optimize this. And now we have a student service interface, which has only one method. And then, of course, don't forget about implementing the interface. So now I will create a new class, and I will call it, first of all, since now we will start implementing our DAO layer or data access object layer. So we will start first of all with an in-memory student service. So I will create in-memory student service, and then I will hit enter. So I see here that I have my class in-memory student service, and then I will implement the student service. All right, of course, it will ask me to implement all the methods. So let's go ahead and do it, and then hit OK. So here I will just paste the code that I took from the previous implementation. So now the find all students, it also returns the same static list that we had as before. And of course, don't forget this service annotation to tell Spring that this is a bean. All right, let's go to our student controller right here. Here you see that Spring is not complaining about this student service because we are using the interface, and Spring will know automatically that for this student service I have already one implementation, because it will know that this class implements already student service. So there is no need to adjust anything in the controller, and if you start the application you will see that everything is working as before. So that's nice. Here we have our application and our code refactored, and our code is looking nice and follows the best practices of software development. Okay, so now since we said that this in-memory student service will handle the students in the memory, so let's go ahead and implement this DAO layer. And let me show you how we can save students, or how we can manage students directly in the memory. Since we said that we want to implement a CRUD API or CRUD operations for our API, so let's first of all start extending this student service with some other functionalities. So here we have the list, find list of students, and before that I want to return the student itself when I want to save. All right, so I want to save the student, and to save the student I want to get the student as object. I will call it student S, and then we have find all students. Let's create also another method that will return a student, and let's call it find by ID. So find by ID or find by email, for example. This, when I pass this string email right here, I want to fetch the student that has that same email. All right, then I want to delete a student. So delete, and then I want to delete it by its email. Since the email should be unique, I will rely on the email for this exercise. Okay, so now we have our 4 operations: post, get, and also another get, and we have delete right here. Let's add a put operation. Also, it will return a student, and I will call it update student, and it will take a student as parameter. All right, now you see here that IntelliJ already is mentioning that we have one related problem, and this is because we have a class implementing this interface, and we need also to implement or to define at least these methods right here. So whether you click on one related problem, it will navigate to there, or also you see this eye icon with the arrow down. If you click on it, it will show you all the implementations of that interface, or if it's only one implementation, it will automatically take you there. So now I will just use the auto completion to implement the methods, and I will hit enter, and you see here that it's listing all the non-implemented methods. All right, so here we have save, we have find all, and so forth. Just one thing here, instead of returning this static list, I will just delete it and return null instead. Okay, so we have all our services. Let's move on and implement them. Now let's implement the third layer of our application. But for now, the repository will not be communicating with a database, but instead it will persist and communicate within the memory. So let's go ahead and create that. First of all, let's create a new DAO or data access object. So right click on the package, then new, and then class. And here I will call it in-memory student DAO. Now we have our class, and then I want to implement the methods that we have defined before. So it will be these ones. So if you go to this in-memory student service, so we will implement exactly these same methods. So first of all, I will just copy them to keep them in my clipboard, and then I will tell you what we will do with it. So I will close this one, and then go back to my in-memory DAO. So since we said that we want to save or persist everything in the memory, so we need to create a buffer for that. And for that, I will create a private list. And then this list, it will hold students, of course. We want to store students. And then let's call it students equals new array list. So now I have my students list. Also, we can make it final. So this will be the storage of my students list. Now I will paste all the methods that we copied before, and all I need to do is to remove this override. I just copied it to avoid retyping everything again. So I will remove this override, and now let's start implementing these methods one by one. Also, I guess I missed the save method. So let's create it. Public student save, and student as parameter. Now I will return null for the moment, and then let's start implementing this. So saving a student is pretty much simple. All we need to do is our student list dot add, and then our student. Okay, so this what saving means. And then we need of course to return the student itself. All right, now to find all students, it's just returning the students. And then find by email. So this one, let's try to implement it. So it's students dot stream. I will stream over my students list and then filter, because I want to filter my students based on the email. So here I will have S for student and then S dot email equals the email that I got as parameter. So email. So I will filter first, and then if I find it, or I can say find first. So find the first occurrence of the student from this list, or else I can return just a null object. Okay, so this is the find by email method. Then let's move on to the delete. And this delete by email. So first of all, I need to search for the student and make sure that I have the student in my list, and afterwards I can delete it. So here I will create a var student equals find by email. And since the find by email takes an email as a parameter, so here I'm gonna store the student, and then if the student is not null, all I need to do is my students dot remove. And then for the remove, we have two methods. The first one is the index, like based on the index, and the second one we can remove by the object. So I want to remove by object. All right, now let's implement this update method. So for the update, first of all, I need to find the index of the student that I want to update, and then I need to replace it in the list. So I will create a var student index equals, and then I want to create an int stream that goes from 0 until the students.size. So here I will use int stream dot range, and the range, as I mentioned, I wanted to go from 0 until the students dot size. And then for each element I want to filter, and then it will give me an index, of course. So I want to filter over students dot get, and then index, and then get email, and I want this email to be equals the S, or the students that I got as a parameter, dot get email. If it's the case, I want to find first, like the first occurrence, or to find any, or else I want to return -1. So -1 just because I need to use it later on to check if I found the student with the correct email or not. So here, if my student index is greater than -1, or different from -1, but greater should be also fine. So in this case, I want to replace the students dot set, and this set methods, as you can see, it takes an index and also a student, or the new object that we want to replace there. So here it will be my student index, and then the student that I want to update. And then once the student is updated, all I need is to return null. Sorry, not null, but all I need is to return the student itself. Otherwise, it will return null, and in this case, I will know that the student was not updated because the email does not exist. That's awesome. Now we have our DAO working fine and fully implemented. Now let's go and use this in our service. But before that, don't forget to make this in-memory student DAO as a bean. And for that, since it's an object or a class which is dealing with data fetching, creating, and so on and so forth, so we need to give it an annotation. So let's use a repository for this. All right, so now let's go to our in-memory student service, and then let's inject our DAO in here. So first thing, I will do private, and I will make it final student DAO, and I will call it just DAO, data access object. And then you see that IntelliJ already will tell me to add a constructor parameter, and here we go. So as I mentioned before, we don't need the auto-wired keyword. all we need is a constructor containing this field or this object that we want to inject. Now let's implement or let's make a call to this DAO. So here for saving student, all we need to do is this .dao.save and then s. So also you can work without this, it's up to you. So maybe let's not confuse you. And then for finding all the students, so it's dao.findAll. Find by email, it's the same. So as you can see, once you implement everything, the rest is so much easy. And then we have the update. So here it's going to be also dao.update and then student. And finally the delete method, which is dao.delete and then email. All right. So now our student service is using now the DAO. So we have the second layer is using the third layer. Now let's go ahead and implement these endpoints within our controller. Now, within our student controller, let's add the operations that will consume the methods that we implemented in our service, student service. So first of all, we have public person, student, save, and this student method, it will take a student as an object. Let's call it student, and then all we need to do is return our service dot save, and then we need to pass the student as parameter. And now to make this method a post method or a post operation, so first of all we need to use this post mapping annotation, and then if you want or if you need, you can add, for example, /save, but since, as I mentioned before, since we are in the REST API, so having this URL with just post, it's totally enough. And then there is one thing which is important. In order for Spring to know that this is an object and this is a request body that comes within the body, and also to make Spring able to map and to serialize this object from JSON to student object, we need to add one annotation, which is request body. Like this, Spring will map or will serialize the student object that we will get as a JSON. It will map it to this student object. All right, now let's go ahead and implement the find by ID or find by email. So since the email should be unique, let's go ahead and implement this method. So it will also return a student. So public student, and I will call it find by email. And then this find by email, it will take a string as parameter, which is the email that we want. So then simply we will return service dot find by email, and then the email. And of course, afterwards, we need to tell Spring that this is an operation or this is an HTTP operation. So we need a get mapping. Since we want to get an object, so it's a get mapping. And here, since we have this email as a parameter, so we have two choices, whether to ask for the email as a path variable or a request param. So for now, let's work with it as a path parameter. So here I will add parentheses and then like this, and I want to have it email like this way. So when you put it between brackets like this, Spring will map it from the URL. And also we need some annotation to map this object right here that we have in our method to the email that we will get in the URL. And this annotation is path variable. So the path variable means that we want to pass this parameter right here in the path of this request. Also, something that I need to highlight right here, since this variable right here is the same as the path variable, so we don't need to specify anything. But in case, for example, I want it to be em right here instead of email, so I will make it like so. Now Spring will not be able to map this email to this em variable name. So we need, in this path variable, we need to pass this email. So when I mention email, Spring will automatically understand that this email goes to this em string variable. Otherwise, we can also bring it back to email, since now you understand how it works. So I will bring it back to email, and then don't forget, if you have a different name, don't forget to add the name to the path variable annotation. And then the find all student, we already have it, and we still now need to implement the final one, or like two other methods, the put and the delete. So I will create a public student, and I will call it update student, for example. And of course, this update student, it will take a student object as parameter, and then all I need to do is to return my service dot update. And then I will pass my student as parameter and semicolon. Of course, don't forget always to add the annotation. So it will be a put mapping. So for this put mapping, it's also, so with this put mapping, it's also not necessary to add a suffix for the path or a URL fragment for it, since it will be understood and it will be clear that this is a put mapping from the operation right here. And this is what I will be explaining later on, how Spring is able to dispatch all the requests that come based on all the parameters that we have right here. And finally, don't forget this request body, since we will get our JSON student in the body of this request. So we need this request body to tell Spring that we need to serialize this object. And finally, we have our public void delete method. And this delete, we said that we want to delete a student by its email. So I will create string email. And all we need to do is, of course, our service.delete, and then email as parameter. So here we don't need to return anything since it's a void. And now all I need to do is to add this delete mapping. And then, of course, we need to pass the email as parameter. So /email. And then for the delete, of course, don't forget to add the path variable annotation. And then let's make sure that Spring will understand everything. So I will call it email right here. All right, that's nice. Now we built our REST API with all the operations that we already implemented and the operations that we spoke about. Now let's go ahead and test this and see how it's going to behave. Now let's start our application and use a tool to test our API. For this, we will be using Postman, since the browser will allow us or help us only make GET requests. And here we want to have or to test several operations: save, put, delete, and get. So for this, we will be using Postman. And let me quickly tell you what Postman is. So Postman is a popular API development tool that allows developer to design, test, document, and share APIs more efficiently. It provides a user-friendly interface for making HTTP requests, testing APIs, and viewing the responses. So Postman offers features for automating API testing and integration with other development tools, which is something that I will cover in a separate course. Overall, Postman helps simplify and streamline the process of API development and collaboration. Now, let me walk you through this tool and tell you how we can use this. So, first of all, you need to click on this plus button in order to have this interface if you don't have it. this is the case you're not familiar with Postman. Then you need to select the API operation, whether it's a get, post, put, patch, and so forth. And then you need to specify your URL or the request URL. So for our case, it's going to be HTTP and then // localhost and then our port 8080, and then we have API/v1/students. All right, so this is a get. Now if I just click send without doing anything else, you see that Postman is returning an empty list. And also here you see that we have this 200 status, which is okay, which is like a successful response from our backend. This means that the request went to our backend and fetched all the students that we have in our system, and then it returned an empty list since we don't have any students yet. So now let's go ahead and create one. So first of all, I will duplicate this tab, and then instead of a get, I will use a post to save a student. Then since our post method in here, it takes a student as a parameter, as a request body, and the student has this information: first name, last name, date of birth, email, and age. So let's provide this information or some of this information. And to do that, you need to go to the body right here, click on it, and then select this type row. And after that, you will have this pop-up right here, and then go ahead and select JSON. So this is the format that we want to pass or to provide to our backend, and the JSON format is always like that since we have one single object, so it's brackets, and then we need to provide each field that we want to pass for our object. And we said that our student has a first name, and here it's really important that you have the same names for the columns right here as you have in your student object. So it's going to be Ali, and then we have last name. It will be Bo Ali, and I will provide also the email. It's contact@aliboucoding.com. So that's it. I will not provide the date of birth or the age, so I will keep it like that. And then let's go ahead and click on send. So then we see that we have this 200 OK. This means that the request was successfully persisted into our backend, and then we see that we have the response because we said I want to return the student after saving it. Now to make sure that this works, let's go back to the first request to fetch all the students, and let's click on it. So you see right here that we have a list that contains only one student. Now let's create a second one. So Jane Boali, and here let's maybe say Jane, and now I will send again this request. I will go back here, I will send it again, and here you see that we have 2 students saved into our memory. All right, now I want to update, for example, this student right here. So here I will duplicate this one, and instead of a post, we know that to update a student we need to use a put, and then we have also the body, and to update it I want to have the email right here, so it's the same one, but I will just want to add the age. So I will add age right here, and it will be, for example, 34, and then I will click on send. So you see that we have the user gets updated, and the response is also 200 OK. Now I will go back and refresh this list and see if it was updated or not. So now you see that this Jane right here was successfully updated, and the age is now 34 instead of 0. Now, as a next step, let's duplicate this one, the first one, the get request, and I want to find a student by email. So the email, let's for example take this one, and since we said that the email we want to pass it as a path variable, so all I need to do is to paste it into this URL right here, and then click on send, and you see that we are returning this student right here. So if I change contact to Jane and click on send again, so here it's returning the correct student from our backend. Now I'm gonna create a dummy student, and here this one just because I want to delete it later on, and then for example here I will make it also dummy. I will send again. You see that the student was saved. I will copy the email address. I will make sure that my student is totally or correctly saved into my backend, and you see it right here. So now I will duplicate this get method, and then I will use delete instead of get. So I will send the request. You see that we have our 200 from the backend, and if I go back to the first one, send again, and this will make sure that I have only 2 students persisted in my backend. That's nice. Well, actually we removed the wrong one. We removed Jane instead of the dummy, but it's fine. I think you see and you get what I wanted to test right here. So this is nice. Now we have a working API, a fully implemented API that persists or manage the students into the memory. Now let's go ahead and understand what happens when you type this URL right here, click on send, how Spring exactly intercepts or interpret these requests. That's perfect. Now you have your API working and running, and everything is managed from our backend. But now I want you to understand something. I want to explain to you something which is super important, and which is how Spring dispatches the requests. So when you type the URL localhost 8080 and /API/v1/students, and with the get method, I want you to understand how Spring is handling that. Also, if you do the same URL and then with the post mapping and a body content, how Spring also is dealing with that. Because if you want to understand Spring and to master this framework, you need to understand all the details about this framework. So let's start from here. As you know, our API can be consumed by a mobile API or a web application. And in this case, or for the previous test we did, we used Postman and the web browser. So when you click on the send button from Postman, this will create an incoming request to our system. And then the incoming request will go to the Apache Tomcat, which is where we have our Spring Boot container running. And then the request will be intercepted, or like the first thing that will receive this request is the dispatcher servlet. And the dispatcher servlet, then it will forward this request to an interface or to an object, or let's use the correct words. It will forward the request to a bean, since you know what is a bean in Spring. It will forward it to a bean of type handler mapping. And this handler mapping will use or try to find the mapped controller, and this mapped controller, it will be stored in a routing table. So here I just want to highlight something. Routing table is not a technical word, or it's not a technical implementation from Spring, but for me to make it easier for you, I just called it routing table. And this routing table, it contains the list of the URLs and also the controller or the method to be invoked. And the method is composed of controller name dot method name. And now let me show you how this routing table is composed, and this already happening when the application starts up. So first of all, it's the method with a get, post, put, delete, and so forth. And then we have the path. So the path is the path that you have on the controller plus the path you have on the method. So this will compose the full path. And then you will have the parameters, and of course the type here matters. All right. So if you have a path like this, if you have a get mapping slash sampath slash string slash integer, and for example, get slash sampath slash ali slash 1, so this is a correct one. And then within the same path, but a different method, post sampath slash ali slash 1, this also correct. And then if you have the same thing, a get sampath and here string and slash integer, and let's say for example that you want to pass the email instead of the first name. So for us as human beings, we can understand that I want to pass a different value or a different field, but for Spring it understands the types. So a string email or a string username or a string first name, for Spring it's all strings. So there is no difference. So if you have the same thing right here, so this one is totally wrong. And here all the paths that here, all this composition should be unique. And to remind you, finally, composition means method plus path plus the path variables or the variables you have within your URI. Then once the path or the fetched path is found, so then it will return to this handler mapping and then return the found controller, and from the handler mapping, Spring will invoke the method as I mentioned before based on the controller name dot method name, and then of course it will go through all the layers of our application, business logic, validation, database, and so on and so forth, and then we will send back the response, and the response will return to the user or the final user as an outgoing request. So generally and way of the code, this is how Spring is dispatching requests from the client to the backend to a specific controller or a method, and so on and so forth. So I hope this was clear. Now let's go ahead, since we understand how everything works. So let's go ahead, git push, git commit, and then let's move to the most amazing part and the most interesting part of our tutorial right here. Now to finish this section, let's go ahead and commit and push our changes. So as I showed you before, I will be always using IntelliJ because I like the UI and the way it works. So now I will just call my commit message, implementing DAO layer, and then let's just commit and push. So that's nice. So now we have everything. We have our code pushed. We have everything set up. We have our API working. Now let me show you how we can add a database to our application and then communicate within this database. Now, in order to connect to a database, first of all, we need to configure our project and add some dependencies. First of all, you know that Spring Boot relies and uses Spring starters. So we have a starter for that, which is the Spring Boot starter data JPA. So this one will give us the necessary classes and configurations in order to connect to a database and manipulate a database. And then, of course, to connect to a database, you need to have the driver for that. You need to have the driver for that database type. For example, if you are using MySQL database, then you need to add the dependency, the MySQL dependency. If you are using Oracle, also you need to have the dependency for that, and so forth. For our example right here, we will be using PostgreSQL. So first of all, let's go ahead and add our Spring Data JPA starter. So here, after the Spring Boot starter web, let's add a new dependency, and then the artifact ID is Spring Boot starter and then data JPA. This is the second one you see right here. I will hit enter, and then of course it's the same group ID, which is org spring framework.boot. And you don't need to specify the version because it will inherit it from the Spring Boot parent. Then if you scroll a bit down here after the Spring Boot data JPA, we need to add the dependency for the PostgreSQL, which will be the driver for our database. So again, another dependency, and now it's PostgreSQL, as you can see here, and then the package is org.postgresql. It's not a different one. You should use the org.postgresql. Alright, so now we have the dependency. We also can add a scope for this one because it's a runtime scope. And then I will make it runtime. And now we have our two dependencies. And then don't forget, of course, to update your project and download the new dependencies by clicking on this icon right here, which is called Load Maven Changes, or by right clicking on this file right here and then Maven and then Reload Project. So it's up to you which one you want to use, or by also running the command mvn clean install -u to install the dependencies. After adding the dependencies, now let's go ahead and give the properties to Spring Boot in order to be able to connect to our database. So to do that, open the resource folder right here and then the application YAML. So here we will start providing properties or the information in order that Spring Data JPA will take and use these properties in order to connect to our database. So for that, it's Spring and then data source and then URL, or also like the the URL is JDBC and then colon PostgreSQL and then colon / and then localhost and colon and then 5432. This is the default port for PostgreSQL, and then your database name. So I will call it student_db. So this is for the URL, and then you need to provide the username. So for my case, it's Alibou, and then the password for that database. Also, it's Alibou for my case. And then there is an information which is not necessary, so it's not mandatory, which is the driver class name. And this driver class name, as you can see here, it's automatically detected. And then you don't need to specify it, since Spring will try to detect that from the dependency that we have. So we have our PostgreSQL dependency, and then Spring will rely on this to add this driver class name. But let me add it just to be consistent and to show it to you. So this is enough to connect to our database. Now let's give some more information to Spring Boot in order to tell him what we want to do exactly. So then at the same level of this data source, we have a property called JPA and then Hibernate. Since we are using the Hibernate implementation, here we have an information called DDL auto. So this means what we want to do exactly at the application startup. And for this, we have 5 options. We have the validate. This will validate only the schema and it will make no changes to the database. None, it will do nothing, or it will disable the DDL handling. Then we have the create, which will create the schema and destroy the previous data. So the create, each time you start the application, it will destroy all the data that you have in the database and create a new one. Then you have the created drop, which will create and destroy the schema when the session ends. And finally, we have the update. It will just update the schema if necessary, and also it will create it if necessary too. So let's keep it to create. And then at the same level of Hibernate, we can also specify or provide the database. So for our case, it's PostgreSQL, and also we can tell the database platform. So for this one, we can enforce, or we can tell Spring which dialect to use in order to generate the queries in the backend. So we will use org.hibernate.dialect, and then it's PostgreSQL dialect. And then to show you how Spring is performing the request, let's also add the property to show the queries. Then we have a property called show SQL. By default, it's false, and now let's set it to true. And then also let's format our SQL queries. So here after JPA, we have properties. And then within properties, we have Hibernate and then format SQL. So as you can see here, we have Spring JPA properties, Hibernate, format SQL, and then let's set it to true. And this will format our SQL queries when we display them in the console. So now let's go ahead first and connect to our SGBD or database management system, which is PostgreSQL. And for that, I will be also using IntelliJ. So here you have this database icon right here, click on it. And then you see that you have this plus icon, which will allow us to add a new data source. And then you can filter for PostgreSQL, select it, and then you will have this default information, which should be fine. And then all you need to provide is the username and password. So as I mentioned, for my case, it's alibou 2 times, and then click on test connection. Then you should have this success or this green success message. Then let's apply, okay, and then it will show up right here. So after that, go ahead, right click on it, and then new. So let me make it clear like this. So then go to new and then database, and let's create our student DB, student_DB. So this is the database that we will be using. Now to make sure that our configuration is fine, all we need to do is to start the application and see that everything is working fine without any exceptions. So let's restart the app. All right, so the application started and nothing is displayed as exceptions or as error messages. So this means that we were able to connect to our database. And now let me show you if you provide something wrong. So I will change the username and password and then restart again, and you will see that Spring will claim or will complain that he's not able to connect to the database. So here, as you can see, we have an exception, and this means that we are not able to connect to our database. So here you see fatal password authentication failed for user alibouq. So let's bring it back as it was before, and let's move on within our implementation. Okay, now the first thing that we need to do is to transform our student.java class into a table or an entity so that Spring and Hibernate will be able to manipulate and manage this object and persist it to the database, read it from the database, and so on and so forth. So as you can see here, we have our student.java with this information except this ID, and I will explain it later on. So in order to transform this object into a table, here we need to have a colon for the student table called ID, first name, last name, date of birth, and email. And the email I want it to be unique, and the ID I want it to be a primary key and auto-generated. All right, so in order to do that, first of all, we need to add some information or some metadata to our student class. In order for Hibernate and Spring to know that a Java class is an entity or a model or a table representation from our application, we have one annotation that we need to provide. The first one is this annotation called entity, and the table is not mandatory, so it's an optional annotation, except if you want to provide more information like a different table name than this student. So for example, if I want to call this student table differently, I need to use this table annotation. Then for this ID, we have these two annotations, ID and generated value. And for the rest of the columns, we have this colon annotation. So the colon annotation is also not mandatory. If we use it, so it's okay. If you do not use it, so Hibernate will take automatically the field name as an attribute name or a row name into our table. And finally, I don't want to persist this age right here. I want it to be auto-calculated. So I need to ignore, or I need to tell Hibernate that I want to ignore this age field, and I don't want to create it in my student table. And for that, I need to use the annotation called Transient. All right. So this is how we are going to transform this student.java class to an entity. Okay, that's good. Now, within this student class, first of all, as we mentioned, in order to make it an entity, we need to use the entity annotation from the jakarta.persistence package. And then we can use also the table annotation. And here we can also give it the same name. And if you want, you can change it. So here it's going to be also student. And then, of course, you see that we have an error right here in the student level. And if I highlight this, you will see that the persistent entity student should have a primary key. So we need to add an ID attribute. I will do it manually. So I will create a private integer ID. So this is gonna represent the ID of this entity. But this is not enough. Just adding this ID is not enough because it's still complaining about the same error. And here, as you remember in the diagram, we need to use the ID annotation always from the Jakarta package and then generated value because I want it to be auto-generated. And then for the first name, last name, date of birth, I will keep them as it is. I will not add the colon annotation because, as I mentioned, it's not mandatory. You can just skip that annotation. But for the email, I want my email to be unique. So I will add the colon annotation. And within this colon annotation, we have a bunch of properties. As you can see here, name, unique, nullable, and so on and so forth. So for me, what's really important is that my student should be unique, or the student email should be unique. So I don't want to have two students with the same email persisted into my database. So I will make it unique true. And then the age, I don't want to persist it. And I will show you later on how we can auto-calculate the age based on the date of birth. So for the age, I will use the transient and always from the jakarta.persistence package. So now we have our entity ready. And then I need to create, of course, getters and setters for this one, for this field right here. So I will generate getters and setters, and that's it. I will just move them to the bottom. Okay, so now if I start my application, I should see that I have a new table in the database called student. So let's try this. So my application is up and running. I will open the database right here. Let me make it a bit bigger. And then here I will just refresh, and you need to display the student DB, which is right here. And within the student DB, let's go for the public schema, which contains our table. So now we have this public and we have tables. So for the tables, we have our student table. If I open it, you will see that I have an ID, date of birth, email, first name, last name. All right. So we don't have the age because the age is transient and it will not be persisted, or it will not be created within our table. All right, now let me show you how we can manage data, or how we can manipulate data from this student table right here. So let me show you how we can create students, save students, delete, update, and so on and so forth. Now, if you want to deal with data in the database, all we need to do is to create an object student repository. So let's call it repository like that, and it should be an interface. And then all you need to do is to extend this interface with one of these interfaces that you see right here. So before that, let me go ahead and explain what is each branch. So first of all, we have this JPA repository. And this JPA repository is split into two branches. So at the same time, it extends the list CRUD repository and list paging and sorting repository. So means if you extend JPA repository, you will have all of this within this interface. But if you don't have, or if you don't want paging and sorting, you can directly extend this list CRUD repository. And also, if you don't have list or if you don't want to deal with lists, you can directly extend the CRUD repository. Otherwise, you can extend the list paging and sorting repository or the paging and sorting repository if you don't have a list. And all of these, they extend from the mother interface called repository. So now it's up to you which one you want to use, depends on your needs. So for now, let's go ahead and extend this JPA repository and create our student repository. So in here, in our student package, right click, new, and then Java class, and don't forget to select interface. So let's call it student repository. Hit enter. So now we have an interface. Now, in order to make it a repository, all we need to do is to extend one of the repositories I just mentioned. So let's extend JPA repository. And as you can see, the JPA repository is a generic interface and it takes two parameters. For the first one is the class and the second one is the ID. So the first one is the entity that we want to deal with, which is the student in our case, and then the type of the ID and the primary key of our entity, which is integer in our case. All right, like this, we have our student repository. So many people, I saw that on the internet, they use the repository annotation here when they extend the JPA repository, but I want to tell you this is not needed because Spring will automatically detect that this is a repository and it will automatically inject it. So there is no need for this repository annotation when you extend JPA repositories. All right, now let's go ahead and use this repository in order to manipulate the data, saving, getting, deleting, and updating. And for that, let's go ahead and create a new class right here. And let's call it DB student service. Hit enter. And in the same way, this DB student service, it needs to be a service, first of all. So Spring will consider that as a bean. And then we need to implement the student service interface. All right, so then we need to define or implement all the methods. So let's go ahead, hit enter. Next step is, let's use our student repository in this DB student service. So let's go ahead and inject it. So I will create a private final student repository and I will call it just repository as a short name. And then I will create it as a constructor parameter. So it will be automatically injected. So in here, within these save methods, I want to use my repository dot save. Now I have a save method, and as you can see, it takes an S as an entity. So all I need to do is to call this method and pass this student entity. Next, to find or to get all the students stored into a database, all I need to do is repository dot find all. And as you can see, this find all method, it will return a list of students. The next one, we have this find by email and we have the update. So let's implement the update first, and then I will go back to this find by email. So for the update, it will be repository also dot save. So the save, it plays two roles. So if we have the ID different of null or not equals null, it will update. Otherwise, if the ID is null, it will update. It will create, sorry, not update, but it will create. So it always uses this ID right here. So if the ID is null, so this means that I want and I need to create a new student into my database. Otherwise, if I have a value for this ID, this means that I want to update my student. Now going back here, so also for this delete, let's go ahead and show you how we can do it. Now, first of all, I want to implement this find by email method. So in order to do that, let's go to our student repository. And here I will create a method that will return a student. And then I will show you the power of Spring Data JPA. So with Spring Data JPA, we can use the query DSL, or like the generated query. So this means that Spring Data JPA will understand from the method name which query to generate behind. So I want to find my student by, and then all I need is to specify the field name with a capital letter. So I want to find it by email, and then all I need to do is to pass the same type email, and that's it. So Spring will create behind a query to find by email, and I will show you that when we test the application. So let's go back to our DB student service, and then to find by email, it's repository dot find by email, and then email as a parameter, and that's it. So now I think you are seeing the power of Spring and Spring Data JPA. And finally, this delete method, so it will be exactly the same thing. So by default, let me show you, we have different methods to delete. So we have a delete, we can pass the whole student, or delete all by ID, and so on and so forth. We can also do the same and implement a delete by email, and like this we will be able to delete a student by its email. So here it's gonna be a void, and now we have delete by, and then email, and then string email, and that's it. So Spring will handle and will deal with this query, and now all I need to do is delete by email, and now my email. That's nice. That's really perfect. So now we have our student, or our DB student service implemented, connecting to the database, dealing with the database, persisting, finding, deleting, and so on and so forth. Now let me show you how we can use this service instead of the in-memory student service, within changing only one line of code, really only one line of code, and this is gonna be super amazing. Now let me explain you the big picture. So first of all, we have our student service, which is an interface, and then we have two different implementations of the student service. So the first one is an in-memory student service, and the second one is a DB student service. So one is persisting into a database, and the other one is persisting into a memory. And both of them will be loaded into our application context as we explained the Spring Bean injection. And now, in order to tell Spring how to inject our preferred service, or which service to use when he deals with the dependency injection, so here we have two options. So the first one, we need to use the keyword qualifier, or we can make one of these services as a primary. So when one of them is primary, this means that Spring will leverage this service. For example, if we give it the primary annotation. Otherwise, if we use qualifier, Spring will use the qualifier even if, for example, this DB student service is primary and we qualifier this in-memory student, so it will be injecting the in-memory service. So let me show you in the code how we can do this. So now I will open again my student controller, and the first thing you will see that we have a warning right here. It's even error message. So it says that cannot auto-wire. There is more than one bean of type student service. All right. So here he found that we have two beans, the DB student service and the in-memory student service. So we need to choose one of them. So first of all, let me show you how we can use the primary annotation. So if you go to this DB student service, and within this annotation, just add the primary annotation. And now let's go back to our controller. You see that this error message now is gone. So now Spring knows that he will inject this DB student service because this one is primary. So if I remove this one, go back to the controller, we see that this error message is back. And now let me inline the code. And here I will use this qualifier annotation. And then with the qualifier, here we have two options. So the first one, when you add this service annotation, we can give it a name. So for example, if I call this one DB, and let me open even the in-memory student service, scroll to the top, and here, for example, I call it EM for in-memory. Now I can use these aliases or these values as the bean name. So Spring will create a bean of type in-memory student service, and it will call it EM or IM. And then for the DB, it will create a bean of type DB student service, and it will call it DB. So now if we go back to our student controller and I say just DB, now it will recognize, and you even see that we have this icon right here. If I click on it, it will navigate me directly to this DB student service. Otherwise, it will, for example, if I want to use EM, it will also navigate me to that one. All right, so this is one option. The second one, I will go back to my student service. I will remove this, and also the in-memory service, I will also remove this alias, and I will keep the service just with the annotation. And if I go back to the controller, here you see that already Spring cannot recognize this bean name, and all I need to do is use DB student service. All right, so Spring by default will use the class name as a bean name. So it will call it by default DB student service like this. And if you navigate, you will see that it will navigate us to this DB student service. So now you have three options. You can choose the one that suits you in order to define or to determine how you want or which service you want to inject into this student controller. Also, if you prefer using qualifier, you have also two ways, whether to use the class name directly as a qualifier, or you can give it a name and use it. So now let's go ahead, let's run our application and test all these changes. Now just start your application and let's test the API. So first of all, for this fetch all students, if you click on send right here, so you see that we have an empty list since we don't have any students persisted into our database yet. And then if we use the same endpoint to persist data, so here I will save a student, Ali, Bo Ali, and then the email, this email right here, and the date of birth. So this is the format that you can provide, and then click on send. So you will see here that we have this response with an ID 1, first name, last name, date of birth, email, and so on and so forth. Now, if we go back to our database and refresh the student table, you will see that we have a line into our student table. So with the email, first name, last name, and so on and so forth. Then let's go back and try to fetch the list of students. Let's go back to this endpoint, click on send, and you will see that it's returning the list of our students. Let's create another one. So let's call it Jane, and for the email, let's also call it Jane. Now let's persist it. And you see that we have the ID number 2, and we have the student that we just saved. So then if I go back, for example, to fetch a student by email, which is the one that we just created. So this one is the old response. Now let's click on send, and you see that it's returning a different object that contains the ID from the database and all the other information. For now, the age is still 0, and I will show you just in a few moments how we can calculate this age. And now if we go back to our student.java class, and then just to remind you that the age is transient, so it's not persisted into our database. Now let me show you how you can calculate this age from the date of birth. So go down to the get age, to the getter method, and here for this get age, instead of returning the age itself, I want to calculate this. And to do that, it's period from java.time and then between. And here I want it to be calculated between the date of birth and then the current date. So local date.now. And then I want to get the years out of it. So because I want to calculate how old is this student. Now just restart the application and let's see how this is going to look like. So now if I persist again this student, so I click on send, and then you see that the age is now 35 because the get method is calculating the age, but this age is not persisted into my table. So let's try with another one and let's change the date of birth. So here I will bring it back also to contact at aliboucoding.com, and here if I say 1950 and I click on send again, so you see that the age is now 72 years old. So this is how you can manage and deal with transient objects, and always don't forget to calculate, if needed of course, you need to calculate the values of that transient object. This is a great achievement. Thanks a lot for following this tutorial, and I hope you enjoyed it. I hope it was insightful and full of information, and mainly I hope this video will help you now start working with the most famous framework, the Spring framework. So now what comes next? If you want to improve more and to learn more stuff about this magnificent framework, just go ahead and have a look on my website. You will find so many useful videos, courses, and a lot of resources where you can learn more about Spring Boot. Currently, I'm working on a microservices course that will cover the microservices architecture and how to deal and how to work with this architecture. Also, it will be a very detailed course. So if you want to get notified and if you want to be informed once this course is released, just go and create your account on my website. I will send emails to all the students which are subscribed there. I will also publish a video on YouTube, so I will inform you guys about this course and once it will be released. So I was really happy having you here. I hope you enjoyed the video and see you next time.